In the vast landscape of modern mathematics, Complex Analytic Geometry by Gerd Fischer stands out as a beacon for those seeking to delve into the intricate world of several complex variables. This book is not just an academic treatise, but a narrative journey through some of the most profound and challenging ideas in contemporary geometry. Written from the perspective of lecture notes delivered across various universities, it aims to bridge the gap between foundational concepts and advanced topics in the field. The text is rich with insights into non-reduced complex spaces that are not always addressed adequately in standard texts, and their associated holomorphic mapping. This makes it particularly relevant for students and researchers who wish to explore deeper aspects of this mathematical terrain, which has significant implications for both pure mathematics and its application. The first part of the book lays down a robust foundation by introducing ringed spaces, morphisms, and sheaves. These are essential elements that form the backbone of complex analytic geometry. Gerd Fischer emphasizes the importance of these concepts through numerous examples and detailed explanations, ensuring that even the most basic notions are thoroughly understood before moving on to more advanced topics. The discussion begins with the introduction of a ringed space, X where X is a topological space equipped with a sheaf of rings, morphisms between such spaces are then defined, providing a framework for understanding how these structures interact. The concept of coherence is introduced here as well, explaining the properties that ensure modules behave in a way consistent with our expectations from vector bundle. Fischer's approach is not just theoretical. He also delves into practical applications by discussing coherent sheaves and their role in complex spaces over various topological bases. This section is particularly enlightening, as it shows how these abstract concepts are not just academic exercises, but have real-world significance. The author introduces important results related to finite type and finite presentation, illustrating how coherence can be leveraged to understand the behavior of holomorphic functions within reduced complex spaces. By the end of this part, readers gain a deep appreciation for the foundational nature of these concepts and their far-reaching implications in modern geometry. Building on the foundation established in the first part, Fischer then explores differential calculus in complex spaces. This section delves into topics such as tangent spaces at points within these spaces, immersion characterizations, regularity criteria for coherent modules, and singular loci analysis in reduced complex spaces. The text meticulously outlines the interactions between various algebraic structures in the context of holomorphic maps, equipping readers with tools necessary for tackling more intricate problems. The discussion on tangent spaces is particularly rich, offering a detailed exploration of how these spaces can be understood through local coordinates and derivation. Fischer illustrates that while some modules maintain finite presentation upon transformation, others may not adhere to this property, highlighting the complexity involved in manipulating coherent sheaves across varying contexts within complex analysis. The chapter culminates with a rigorous examination of differential forms and their role in characterizing singularities. This part provides readers with a comprehensive understanding of how local properties can be extended globally over the structure of complex spaces, making it an invaluable resource for those seeking to deepen their knowledge of this topic. The third part of the book focuses on analytic subsets within reduced complex spaces and their associated coherent sheaves. Fischer begins by discussing the significance of analytic subsets, noting that a rare subset does not intersect with any irreducible component. He then delves into the properties of closed subspaces defined by coherent ideals, establishing an equivalence between local algebraic structures and geometric configurations through coherence theorems. The discussion also includes examples illustrating how certain constructions can lead to different dimensional outcomes in complex spaces. Fischer's analysis extends to hypersurfaces, emphasizing that these are defined by non-zero divisors within coherent ideals. He provides specific instances where the ideal structure can result in varying dimensions and geometric interpretation. This section underscores the necessity for precise conditions, such as being a principal ideal, to accurately classify closed subspaces and understand their geometric implications within larger complex structures. The text also explores constructible sets, highlighting that they are inherently analytic if every compact analytic subset is finite. It provides methods to prove this through established lemmas, emphasizing the importance of local properties in establishing global coherence. The discussion concludes with an examination of projective varieties associated with coherent modules over complex spaces, illustrating how these structures interact under module axioms and homomorphic mapping. The fourth part of the book focuses on holomorphic maps between complex spaces, exploring their properties and implications. Fisher begins by discussing embeddings, immersions, and biholomorphic maps, providing clear criteria for each classification. He explains that an embedding is characterized by a closed subspace defined in such a way that the mapping retains a biholomorphic character. The necessity of bijections and surjective mappings between local rings further clarifies the structure of these mappings and their implications for the topology of spaces involved. The discussion on gluing data provides insight into how complex spaces can be constructed from families of open subspaces with biholomorphic maps between them. This section emphasizes universal properties that allow for unique mappings under specific conditions, ensuring coherence across different pieces in the family. The construction of fiber products is also explored, highlighting their role in creating new complex spaces based on existing ones while preserving individual characteristics. Fisher then delves into the diagonal map, which encapsulates self-referential relationships within a space by embedding it into its product structure. The text concludes with definitions and examples that clarify how algebraic structures underpin geometric interpretations in complex analysis. This comprehensive examination underscores the interconnectedness of various aspects in complex geometry, revealing profound insights applicable across multiple mathematical domains. The final part of the book tackles advanced topics such as proper modifications, meromorphic functions, and their properties. Fisher discusses proper modifications as holomorphic maps that are not only proper, but also maintain specific properties concerning an analytic set, A, G, within the target space. He emphasizes that one can always choose A to be minimal, capturing essential characteristics without unnecessary complexity. Examples such as normalizations and modifications with analytically rare centers illustrate these principles. The discussion on meromorphic functions is particularly rich, highlighting challenges in defining them due to local behavior near points where they may not be well defined, poles. By constructing sheaves that encapsulate this behavior, Fisher articulates how meromorphic functions can retain properties reminiscent of holomorphic functions despite their added complexity. The concept of poles and indeterminacies leads to discussions on pole varieties associated with meromorphic functions. Fisher concludes the book by referencing significant contributions from mathematicians like Hurwitz and Weierstrass. He asserts that if multiple meromorphic functions exist over compact, complex spaces, they are invariably algebraically dependent on each other through some non-zero polynomial. This conclusion underscores the deep interconnections between algebraic geometry and complex analysis, providing a comprehensive overview of foundational theories. Complex Analytic Geometry by Gerd Fischer is a testament to the power of geometric intuition in mathematics, offering readers a profound understanding of several complex variables. By weaving together foundational concepts with advanced topics, Fisher invites readers to explore the rich tapestry of complex analytic geometry and its applications.